Greetings, my 2 liter of YouTube followers. We have another Barney Oliver amplifier update and some interesting stuff on this one. I think I have found a design flaw in this amplifier, and it requires a modification. And I believe that there's a good chance that most, if not all, of the remaining Barney Oliver amplifiers are going to have some iteration of this problem. So what is this design flaw that the gods at HP somehow overlooked? Well, it's in the grounding, and let's get to that. So you can see I've got the power supply board up, and the last videos I've been cheating you out of a look at the underside of this thing, so now you can see it. Interesting stuff going on here. So let's take a quick look at how it's laid out. We got the 2 main filter caps right here, and they screw in through these 4 holes here. So these 2 terminals here in the middle, these are common, one positive, one negative, and then these are the rail ones, outputs here and on there. Okay, so you got this ground in the middle here, and coming over is this little through hole via here that's filled in with solder, and on the other side you can see the light shining through the board. There's 3 traces back there. It goes through to the middle one, okay, and then that middle one comes to this blue wire. Now I've added that blue wire. What used to be here was the center tap from the transformer. If you recall from the earlier video, that was a solid core wire and very, very thick, and it broke, and I wound up replacing it with a stranded wire. Well, I have wound up replacing it again with basically the same stranded wire, but what I've done is I've taken the center tap off of this, and I'll show you why in a second. The center tap has come off of here and is now going to an eyelet where I've soldered it in with 2 other wires. Okay, so the wire coming from this center trace goes to this eyelet. The center tap is that other blue wire that's coming in here and is also soldered into the same eyelet, and this black wire coming out here is soldered into that eyelet, and that's coming up and grounding over here. And I'll show you why I've done that in just a second here. If we look close at this hole, that is where this circuit board mounts to the chassis against an aluminum standoff. It is that standoff right there, and the interface between that aluminum and the gold plating and or the copper underneath it has caused this gray, it's either an intermetallic or it's some sort of, it's some sort of metal on metal weirdness going on there. And that's a real problem because this circuit was relying on that as a ground. Same situation over here. That same gray oxide where it mounts to the chassis, and even up here on the corners of the board, that same gray oxide. Now on the corners it doesn't matter because there's no electrical connection there. Those traces, it won't focus, come on. Those traces down there don't go to anything. But you can see what happens where that stud meets that gold or copper underneath it, and it does that. And that becomes a real conduction problem, and it becomes a poor ground. And so that had to be redone. So why did I pull the center tap off? Well, because look how this thing is laid out. So we've got two ground buses really on this thing, right? We got the ground bus over on this side of the circuit board, which is the 2 commons of the capacitor. That's your plus and minus 40 rails, and they're all grounded through here. On this side through that stud. That's where they go to the chassis. Where they go to the center tap of the transformer is through this through hole via here to there where the center tap of the transformer used to be. Over here, this center ground here is not connected to that one. It is a separate ground, and it was grounded through the chassis here only. So that means that the return path for this side is through the chassis, out this little mechanical interface here, right, through this stud into the chassis, across the chassis, up through this other stud, through this mechanical interface here, which is corroding, and then across this trace, through that through hole via, and then back to the center tap, which means that this whole side of the circuit had this ridiculous circuitous grounding path of going off the board, through a mechanical connection, through the chassis, through another mechanical connection, back onto this side of the board, then through a hole to the other side of the board, and then out to the center tap. Crazy, right? So the solution that I came up with is I pulled the center tap off here where it was. And as I said before, I soldered it into this eyelet with 2 other wires. I would have soldered it in with 3 other wires if the eyelet had been big enough, but it wasn't. So 2 other wires, one of them grounds to where the center tap used to be. So, I've only increased the distance of the center tap to this trace by the distance of this very thick wire. And now we're grounding this side of the circuit through this wire right here, which is soldered in there. And this side over here, we're now grounding through an eyelet, which I added. And what I did was I soldered that eyelet on like this. And it was a cool little trick I figured out. In order to hold that eyelet there, I just got that eyelet nice and centered over that hole, that screw hole there, and put a screw and a nut through it to hold it in place while I tacked it in and soldered the wire to it. And as you can see, all the eyelets are soldered connections, not crimped connections. So they're gonna last real good if this fucking thing will focus. Okay, so yeah, so that's that. And the other reason I had to take this up, as it turns out, was that one of these diodes down here was bad. That one down there was bad. I went and replaced all 4. So this one does, these 2 diodes here do the positive 50 rail. These 2 do the negative 50 rail. So I did both of those, or all 4 of those, because one of them was cracked. And even though it was testing good on my meter, and it tested good when I checked all the diodes, when I replaced all these capacitors and fixed the missing voltage rails, as it turns out, one of those diodes was bad and it was cracked, and sometimes it would work and sometimes it wouldn't. And the result was looking at the waveforms of these power supplies on the scope, and I saw that this one had 60 hertz ripple in it versus 120 hertz ripple, which is what you would expect with a pair of diodes. You'd expect to see 120 hertz ripple on your line, not 60 hertz. So when I saw 60 hertz, I figured out, I got a bad diode there. So doing that reduced the hum floor of the amp even further. So now we're going to put it all back together. I've already tested this. This works. This does a great job of bringing the hum of the amplifier way down. But I wanted to take it up and show you, because good chance that if you have a Barney Oliver amplifier, it is suffering from this. I don't see why it wouldn't. It just seems to be a metal problem between between that kind of circuit board and that kind of stud. So let's take a quick look at some of the cleaning and the Davin the stepped attenuator that I tried unsuccessfully to get apart. We'll show you that. Here, hang on just a second. So this is the beautiful Davin stepped attenuator that is in this thing. 31 steps, 2 dB per steps, 10 k ohm. I tried to get this thing apart so that, obviously this deck right here, very easy to clean. You just take this cap right off, and that's as easy as pushing in this little button and twisting the thing off. You would think that because there's another little button there, that twisting the rest of this thing apart would be really easy. You'd think that, but you'd be wrong, because despite there being... Oh, and I need to tighten those little set screws up. I forgot about those guys. But despite the fact that those set screws are loose, this thing ain't going anywhere, because you can see that there's a pin driven through there, and it's kind of been swedged in and press fit in there. I'd need a special tool to get that out. I tried tinking it out with a punch and a hammer against an anvil. It's very tight in there. I don't want to damage this thing. Getting in there to clean it, I'm not sure it's necessary if you exercise this thing a lot, because look at the construction of that. So you've got, if I can hold the camera still, you've got an inner ring that's continuous all the way around. It's in there by the shaft. And then on the outside, you've got the contacts for the various resistances. And you've got two very stout spring-loaded little spider contacts that bridge the inner ring to the outer ring. And those contacts are very thick. And those wipers have a lot of pressure on them. So I think that if I exercise this thing back and forth many times, that it will self-clean. The metal-on-metal contact will wipe any crud that's on there away. I did have this thing completely out, and I shot footage of it. I had to throw that footage out, unfortunately. The front of it, you get access to the click, and the click is really stout as well. It's a stainless steel ring welded to the shaft, and it has a spring-loaded ball bearing detent on it, which had old dried up grease. I cleaned off all the old grease with isopropyl alcohol, put some new grease on there, and now I can actually turn the shaft without a knob on it. It's stiff, but I can do it. So it definitely helped some. Just wanted to show you that. These are all loose because I have the faceplate off. One of the things I wanted to point out about working with a nice faceplate is that you got all the nuts and screws and stuff you want to take off. See right there, it was the power switch that went there, and it didn't have a regular hex nut. It had a knurled nut, and it was on so tight I couldn't get it off with my fingers, so I had to use pliers. And so what I did was I put blue tape on the faceplate to avoid scratching it. And similarly, if you take a piece of blue tape and put it over your hex nut driver like this, then it won't make circular scratches on the faceplate when you take the screws and stuff off. And if you accidentally glance it against the thing when you're working, you won't scratch it either. This is what the amp looks like with the faceplate removed. And with the sides off, we're going to refinish the sides. It actually says right in the owner's manual that the sides are provided without finish and should be gone over with 600 grit sandpaper and finished to your choice. It would appear that the previous owner of this amplifier never did that and left the wood raw and dry. So we're going to give it a sand and put a nice finish on it, just like the owner manual tells us to. And let's see here. You can see there I've got the original transistors reinstalled. There's a reason for that. I've been talking with people that say that these transistors should be just fine, and my listening and initial measurements prove them right. This amplifier seems to be perfectly happy with these. They're currently in there without any heatsink compound, but we're going to fix that as soon as the Tech Ingredients heatsink compound arrives. And that's it. So we're going to put this thing back together. And in the next episode, we're going to bench it out, and we're going to start taking some measurements and looking at its performance. Good news on that front, it seems to put out 70 watts instead of the 50 it's rated for. It seems to be perfectly happy to put out 70 watts with very low distortion. So more coming soon.